Good morning. Today we'll be doing numericals of electricity, and that too with the portion of series and parallel combination of resistances. So let's begin with the thing. Here comes the first question, which says that the following combination has an effective resistance of 8 ohm. Calculate the value of R. See here. So first of all, let's see what is the basic figure says. It says that the current is passing from here. It goes and bifurcates over here. Is it clear? Now it has to come at this point, and we know that whenever it starts going from there, there are two ways to follow it. If there are, remember that I told you, if there is more than one way of current, that means they are connected in parallel. So we'll say that these two are connected in parallel. Again, when we move to the forward, then this particular set, as we can see, this is connected with R in series. Got it? So let's see how to solve this. First of all, let me find the total value of R1 and R2. We know that in parallel combination, 1 upon R is equal to 1 upon 10 plus 1 upon 15. If I take the LCM 10 and 15, the answer will be 5, 2, 3, 2, 1, 3, 3, 1, 1. 3 to the 6, 5 to 30. So 1 upon R is equal to 30. That is 3 plus 2. It comes out to be 5 upon 30 or 1 upon 6. So the value of R, I'll just say R dash. R dash will be 6 ohm. This is because we have to reciprocate the final answer. Now, we know that if I make that equivalent diagram for this system given, it will be like 6 ohm this one, and this is R. Is it clear? Now, as it is saying that the effective resistance is 8 ohms, we can see it here. The effective resistance is 8 ohm, but they are connected in series. So, for series combination, I know that 6 plus R is equal to 8 ohms, or R is equal to 8 minus 6, and the answer comes out to be 2 ohm. Is it clear? So let's move on to the next question. Let's see what the question has to say. Find the equivalent resistance of the following circuit. We need to find the resistance for the given circuit. Now here we can see that, look at the way the current is flowing. If the current flows like this, it goes from here, then these two are in parallel and these two are also in parallel. Got it? These wires are connected as it is. So I'll just try to solve it out. I'll take out the system here. I'll take this one as one system and this one as another system. And these 4, 1, 2, 3 and 4, they will be connected in series. So first of all, let me find for this 1 upon 2 plus 1 upon 2. The answer will be 2, 1 plus 1, 2 by 2. And the final answer is 1 ohm. Is it clear? Now for another combination, the answer will be 1 upon 1 plus 1 upon 1. The answer is 1. So 1 plus 1, it is 2 by 1, and the answer will be 1 by 2 ohm. Now 1, 2, 3 and 4, they all are connected in series. So 3 plus 3 plus 1 plus 1 upon 2. The answer will be 3, 3, 6, 7. 7.5 ohms. Got it? So let's move on to the next question. Let's see what does it say. Figure shows the circuit diagram for three resistors R1, R2 R3 connected in parallel. You can see it as it is here. V is battery of 6 volts. It's showing 6 volts over here. If values of resistance are 5, 10 and 30 respectively, then calculate the value of current through each resistor, the total current and the total effective resistance of the circuit. So, first of all, let's find out the total resistance. We all know that these are connected in parallel. So, I'll just make it 1 1 upon 5 plus 1 upon 10 plus 1 upon 30. See, the value of R3 is 30 ohm. So, if I take the LCM, it's 5, 10 and 30. So, 5, 1, 2, 6. It's 2, 1, 1, 3, 3, 1, 1, 1. 5 2s are 10, 10 3s are 30. So, the LCM is 30. It will be 6 plus 3 plus 1. And the answer is 10 upon 30. And R will be 3 ohms. Is it clear? Now, what is the next question they have asked? They are asking for the total current in the circuit. We know that the total current will be from the formula V is equal to IR, I is equal to V upon R. We know that the value of V over here is 6 upon the total resistance is 3. Got it? So, it will be 2 ampere. The current in the total circuit will be 2 ampere. Now, the another question what they have asked is the value of current through each resistor. Since they are connected in parallel, we know that if they are connected in parallel, each resistance will have same potential difference across its end. So, I can write here 6 volt, 6 volt and 6 volt. Is it clear? Now, to find current in each, I'll just find out. It's I find that will be V upon 5. And what is V? It's 6 upon 5 ampere. For I10, it will be 6 upon 10. That is 3 upon 5 ampere. And for I30, it is 6 upon 30. That is 1 upon 5. Is it clear? Ampere. We can check the answer also. How will we check the answer? The very easy way is the total current should be equal to the value of, by adding what we get from there. So, to check, I'll just write 6 upon 5 plus 3 upon 5 plus 1 upon 5. 5, 6 plus 3 plus 1, 10 upon 5. And answer is 2 ampere. Hence, the total current which we found, it is 2 ampere. It is coming exactly equal to that thing. Kindly note down these questions. So, let's move on to the next question now. Yes. It says that 24 volt battery is connected to the element of resistance given below. Find the total effective resistance, current, total current flowing through the. Next, in hydrogen atom, an electron revolves in a circular path of radius 5 into 10 raised to power 11. 5 into 10 is to power minus 11 meters with a speed of, the velocity given here is 2.2 into 10 is to power 6 meter per second. Calculate the equivalent current. Yes, they already have asked it. So we know the formula for current is I is equal to Q by T, that is NE by T. Is it clear? Here N is 1, so I is E by T. But for T, we need to find the total time. So how will you find the total time? We know that distance traveled is velocity into time, or time is equal to distance upon velocity. In this case, it is moving in a circular path. We can see it revolves in a circular path. For circular path, the total distance traveled is 2 pi r upon velocity. You can see it here, 2 pi r upon velocity. So first of all, let me try to find out the time now. Let's see what does it say. So T is equal to 2 into, what is the value of pi? It's 22 upon 7 multiplied by R. 5 into 10 is to power minus 11 upon, what is the value of velocity? It's 2.2 into 10 is to power 6. Is it clear? So I'll just try to cut it out. The answer will be 10 here, or T is equal to 5 to the 10 into 10 into 10 is to power minus, if I cut it down, if take it upwards there, it will be 10 is to power 6, and 6 plus minus 6 minus 17 upon 7, or T will be equal to 100 upon 7 into 10 is to power minus 17. Got it? Now for solving, we have this value of T over here. Now we'll put this value here. So the value of current will be, equivalent current will be, charge of one electron is 1.6 into 10 is to power minus 19 upon, what is the value of T? It's 100 upon 7 into 10 is to power minus 17. So the final answer, when we'll solve this all, it will be 1.12 into 10 is to power minus 3 ampere. Is it clear? See, this is the way how we need not solve it totally here. It can be further solved along with, so that we can cross out the things which are common over here. Let's move on to the next question now. If the graph of a conductor of the potential difference V and current I is shown in figure. See, this is I hope it's visible. This is V. Calculate the resistance of the conductor. So we can easily find, we know that V is equal to IR, or R is equal to V upon I. Here in this case, if I take V 20, which is followed by here, it becomes 2. So the answer is 10 ohm. We all know that for Ohm's law, the graph is always a straight line. See, it's going like this over here. Got it? Now, let's move on to the next question. A solid cube of silver has mass of 84 grams. What is the resistance between opposite faces? First of all, let me show you how the cube looks like. Cube is like this. Got it? So what's asking is in this surface and in this surface. So let's see how to start with the question. First of all, we know that the formula is R is equal to rho L by A. Since they have not given the side of the cube, we need to find the side of the cube first. And how will we find it? We know that density is mass upon volume. Okay. Now the density given is 10.5. Okay. And the mass is 84 upon volume. So the volume will be equal to 84 upon 10.5. Students, we need to look at one thing. It is in grams and it is also in grams. So it's okay. We can solve it further. The answer of this will be somewhere around, if I solve it, 10, 10.5, this comes out to be 10, 10 to 8. Or just leave it as it is. There is no issue for this. The answer will be 8 into 10 raised to power minus 6 meter cube. Is it clear? The approximate answer will be this. So by using this, we will find the side first. We know that volume is L cube, that is side cube. So V is equal to 8 into 10 raised to 8 into 10 raised to power minus 6 is equal to length cube, or L is equal to under root of 8 into 10 raised to power minus 6, and L will be 2 into 10 raised to power minus 2 meters. We find the length till now. But what we need to find is resistance. So how to find the resistance now? R is equal to, what is the value of rho? 1.47 into 10 raised to power minus 7 ohm meter multiplied by, what is length? 2 into 10 raised to power minus 2. Is it clear? And of course, for the area, we need to find the area also. The area will be 4 into 10 raised to power minus 4. And the final answer will be, that is 0.735 into 10 raised to power minus 5 ohm. When we solve it properly, the final answer will be this only. So look at the approach of the question. The way the question has told or has asked to find the value of side or length of the wire. It has given density, then mass, then everything, and then only we can find the answer. So first of all, read the question twice or thrice so that you can understand the question in a better way. Next, move on to the next question now. What is the resistance from A to B? Okay, in the network, this point is A and this point is B. Okay, let me tell you one thing. These are known as connecting wires. Okay, and these connecting wires, whenever true resistance are present between two connecting wires, they are said to be connected in parallel. So if I see from A to D, that is, if I make the equivalent diagram for the circuit, it will be this. See, between this and this, these two are in parallel. These two are in parallel. Between this and this, these two are in parallel. So I have already included the middle one. I'll once again put it here and another value of R here. Now they are connected in parallel. So 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So the answer will be 3 by R, or R is equal to R by 3. This is the final answer. So thing to be noted down is, although they are looking in series, but due to this presence of these connecting wires, they all are connected in parallel only. Let's move on to the next question now. A metallic wire of resistance R is cut into 10 parts of equal length. Now, what does this first line say about? It says that when wire is connected into equal parts of length, and we know that resistance is directly proportional to length only. So, resistance will become 1/10 if the length has become 1/10. Two pieces each are joined in series. So, what does it say? Let it be, if it is connected, total length of the wire was, if this was the total length, then for each piece value of R is R by 10. Got it? It says that two pieces of such are joined in series. Okay, then I'll say this is R by 10, this is R by 10, and then 5 such combinations are joined in parallel. So look at this: 1, 3, 4, 5. Each has value of R by 10. Okay, now we need to find what is the value of this series combination. We know that in series we just directly add R by 10 plus R by 10. The answer is 10, or I'll just put it multiplied by 1 multiplied by 1, R plus R, that is 2R by 10 or R by 5 for each set. Now such 5 sets are connected in parallel. So we know that 1 upon Rp is equal to 5 by R plus 5 by R plus 5 by R plus 5 by R and plus 5 by R. We have to reciprocate it. Okay. Now 1 upon Rp will be equal to total R, and 5, 1, 2, 3, 4. 5 plus 5 plus 5 plus 5 plus 5. The answer comes out to be 25 by R. Now again we have to reciprocate it, because in parallel combination we always reciprocate the final answer. So the Rp will be equal to R upon 25. Is it clear? Please note down this question. So after this, let's move on to the next question. Now this is the tricky one. Let's see what does this say. Three resistors are connected as shown in figure. Through the resistor of 5 ohm, the constant current of 1 ampere. That means 1 ampere current is flowing through this resistor, and total amount of current flowing through this will be also be 1 ampere. So okay, what we need to find in this question is total resistance and current through each resistor. So we can find that easily. See, I tell you one thing. This combination AB is connected with BC. In series. So I'll say that this one is in series with this BC. Got it? Now, first of all, let me find out total resistance of BC. It will be 1 upon 10 plus 1 upon 15. If I take out the LCM, 10 and 15, so 5, 2, 3, 2, 1, 3, 3, 1, 1, 3, 6, 5, so 13. So So 30 and 3 plus 2, it comes out to be 5 by 30, or RBC is equal to 6 ohms. Okay. Now, since the RBC has 6 ohm total of this thing, and we know the current passing is also 1 ampere. So, potential difference across BC is 1 into 6, that is 6 volts. Is it clear? And potential difference across AB is also 1 into 5, that is 5 volts. Okay. Now, what has been asked is, we need to find the total amount of current flowing through the circuit. We know that in parallel combination, current passing through each resistor. So, we need to find that total potential difference across BC is, we find out answer 6 volt. So, across this also it will be 6 volts, and here also it will be 6 volts. Got it? So, now I can put it, if I need to find the value of I10, that is current in 10 ohm resistor, it will be V upon R. It comes out to be 6 upon 10, that is 0.6 ampere. And for I15, it is 6 upon 15, that is 0.4 ampere. Is it clear? Now, again, one more thing what we can ask is total resistance. So, total resistance is 6 plus 5, that is 11 ohm. Got it? So, we have done this question also. Let's move on to the next question now. See, in the circuit diagram, find the total resistance. It's very easy. We know that this portion is in series, because the current is flowing from these arms, these two are in parallel. But to pass current from this end to this end, it has to pass through each. So, they are connected in series. So, I'll find out the answer. It's 3 plus 2, 5 ohm. Now, I can make another diagram. It says 5 ohm upon 5 ohm. Is it clear? So, total resistance is 1 upon 5 plus 1 upon 5, that is 2 upon 5, or final answer is 2.5 ohm. Got it? Now, current through ammeter A. So, since it is connected here, it will show the total current flowing in the circuit. So, total current will be given by I is equal to V upon R. We know that value of V is 4 and R is 2.5. Is it clear? So, total answer will be 4 upon 2.5 ampere. Got it? Next, move on to the next question now. For the circuit diagram given the following, what is the value of current through 6 ohm and potential difference across 12 ohm? Now, this is the tricky one. So, I'll tell you how to solve it first. It is given that 4 volt here. Got it? Now, since these are connected in parallel, I can say that 4 volt of potential differences across these arms. So, let me find out the current through arm AB. So, current through arm AB will be equal to V upon R. But what is RAB? It is 6 plus 3, 9 ohms. By putting this value here, the answer will be 4 upon 9 ohm. So, the current flowing through this wire is 4 upon 9 ohm. Okay. Now, they have asked through 6 ohm. since these two are connected in series and we know that in a series combination current is same, so I can say that I6 is 4 upon 9 ohm and will give, ampere. It's also ampere. And you can write the answer, since it is in series with 3 ohm. Got it? Again, in next question what he has asked is potential difference across 12 ohm. So first of all we need to find the total resistance, that is RDC, and the answer will be 15 ohm. Is it clear? Now what will be the total current here? IDC will be equal to V upon R, that is 4 upon 15 ampere. Got it? Now in this also there is 4 upon 15 ampere current, and here also it is 4 by 15 ampere current. Clear? Now we have to find the potential difference across 12 ohm. So we'll write it, V12 is equal to, what is the value of current? 4 upon 15 into what is the value of R. So I'll just solve it like this. So V12 will be 3 4s are 3 5s are for the 16 upon 5 volts or 3.1 volts. Is it clear? So this is how we solve this kind of numericals. Each and every time you just write across it what are the things given. It will become easier for you. Let's move on to the next question now. A resistance of 8 ohm is connected in parallel with another resistor X. It says that resistor of 8 ohm is connected with another resistance X. The resultant resistance is 4.8. So R total is 4.8 ohms. What is the value of resistance X? So we need to find the value of X here. We know that 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Here Rp is 1 upon 4.8 is equal to 1 upon 8 plus 1 upon X. Is it clear? Now, to solve this further, I can write it in such a way that 1 upon X is equal to 1 upon 4.8 minus 1 upon 8. Is it clear? Or else I can write this 48 as 1 upon X is equal to 10 upon 48 minus 1 by 8. So, 48 and 8, the LCM will be 4, 1, 2, 2. 4, 3, 1, 3, 1, 1. 4, 4 are 16, 48 only. So, 1 upon X is equal to 48, that is 10 minus 6, or 1 upon X is equal to 10 minus 6 is 4 upon 48, or X is equal to 48 upon 4. The answer is 12 ohm. Is it clear? This is how we solve this question. Now let's move on to the next question. Four resistance of 16 ohm each are connected in parallel. 4 such combinations are connected in series. What is the total resistance? So first of all, let me find out the total resistance when they are connected in parallel. So when they are connected in parallel, I know that 1 upon Rp is equal to total is 4 ohm for 1. Now such 5 combinations are connected in series. So we know that when it is connected in series, the answer is 4 plus 4 plus 4 plus 4 plus 4, 1, 2, 3, 4, 5, and Rs will be equal to 20 ohms. We need to look at the approach of the question. What is it saying? See, if I would have made a diagram, it is quite possible it might be easier for someone or it might not be easier for someone. So what I have done is I have taken out for one set and then I have added in series. Let's come on to the next question now. In a circuit given alongside, the current across 5 ohm resistor is 1 ampere. It is ohm, not watt. Find the current flowing through other 2 resistors. Yes. What they have told is we need to find the potential difference first, because they have not given the potential difference. So what I'll do is I'll find out the potential difference across 5. Since it's given that the current flowing is 1 ampere, so 1 into 5, that is 5 volts. Now we know that when resistors are all connected in parallel, everyone will have the same potential difference. So I can write that the total potential difference is 5 volt for each. Got it? So find the current flowing through the other 2 resistors. Now I know that it is also 5 volt, it is also 5 volt. So finding out the current in each, I'll write I4, that is V upon 4. And what is V? It is 5 by 4 ampere. And in case of I10, the answer is V upon 10, that is 5 upon 10 ampere. These are the final answers. They can be further resolved also. It's up to you. Got it? Now, let's move on to the next question now. Now look at this. It says that calculate the effective resistance between 2 point A and B in the find. So I can see that current is flowing from here and it goes into 2 paths. But for coming from here to here, it has to cross these 2. That means these 2 are connected in series. So what I'll do is 1 plus 2, it will be 3 ohm. Now this one is connected with parallel 1.5. Is it clear? So to find out the total answer now, I'll just do 1 upon 3 plus 10 upon 15. We know that 3 and 15 has LCM 3, 1, 5, 5, 1, 5, 15. So it is 5 plus 10. And the answer is 15 upon 15. That is 1. So the total resistance is 1 ohm. Please note down these questions. Right. Let's move on to the next question now. Let's see what does it say. Calculate the effective resistance in the shown figure. We know that the current goes like this. Now it has to pass through this to reach here, and same goes for this one. So I can say that it's 1 plus 1, that is 2 ohm, and again 1 plus 1, that is 2 ohm. Got it? Now the equivalent diagram for this will be 2 ohm like this. Okay? Now we can see that these are in parallel. So 1 upon 2 plus 1 upon 2, it is equal to 2 1 plus 1 or 2 upon 2, and the answer is 1 ohm. We can simply learn the methods also in a different way. Now let's move on to the next question. How can the three resistors of 2, 3 and 6 ohm can be connected in series to give total resistance of 1 ohm? Now this is known as the hit and trial method. We need to set certain combinations and we need to try the equivalent resistance so that we can get the final answer. So let me try. What if I try one? What if I connect them in series? 2 plus 3 plus 6, it comes out to be 9 ohm, which is not possible because the total answer has to be 1 ohm. So we cannot do like this. Try 2. In this case, if one of them is connected 5 ohm and if it is connected with parallel with 6, so the answer will be 36 plus 5, that is 11 upon 30 or 30 upon 11. So this cannot be the answer. Got it? Now what if I connect them all in parallel? So let's see. It's 1 by 2 plus 1 by 3 plus 1 by 6. The answer will be 6 here, 3 plus 2 plus 1, and the answer is 6 by 6. Yes, and this is the equivalent resistance R. Whenever these kind of questions are there, just think about the various combinations first before getting the final answer. You might get into 2 or 3 trials, but of course you'll be able to do that. Now let's move on to the next question. Three resistors 12, 15 and 20 ohms are connected first in series and then in parallel. What is the equivalent resistance in each case? So first of all, let's see in series combination. In series it will be 12 plus 15 plus 20. The answer will be 747 ohm. For parallel combination, 1 upon 12 plus 1 upon 15 plus 1 upon 17. Okay. Now let me find out the LCM for this. So the LCM for this will be, I'll say it's been parallel. So 2, 6, 15, 17, 2, 3, 15, 17, 3, 1, 5, 17, or 5, 1, 1, 17, 17 like this. So the total LCM will be 2 to the 4, 4 3s are 12, 12 5 is 60, and 16 17. So 60 into 17 is 0, and it will be 1020. Since they are connected in parallel, then it is, I have taken the wrong values over here. Let me correct it first. The answer is 20. 1 upon 12 plus 1 upon 15 plus 1 upon 20. Okay. Now 12, 15 and 20. I'll just put it 2, 6, 15, 10. 2, 3, 15, 5. 3, 1, 5, 5. 5, 1, 1, 1. 5 3 is 15, 15 2 is 30, 32 is 60. So the LCM is over 60 here. Now it will be multiplied by 5. It becomes 5 plus 4 plus 3. So the answer is 9 and 3, 12 upon 60. Or we'll inverse the answer. Rp will be equal to 60 upon 12 and the answer is 5 ohm. Is it clear? So today we have done around 19 questions in this question. In very next class, we'll do the level 2 and the power questions. Till then, happy learning. God bless you.